Also, it is an honor to have once again, the opportunity to meet students and colleagues from India, and especially from Hari Bhai Desai College. And it's my privilege and pleasure on behalf of Université de Béjaïa to welcome you. So I would like to grace all of the committee, Shri Manyar Sir, Shri Power Sir, Professor Sagar Jagtap, and the principal of college, Professor Ganaj Raoud. The topic of discussion today's webinar is on photocatalysis for dye degradation. So without delay, I give the floor to my head of Process Engineering Department, Dr. Fatmi. Please, sir.
Thank you. Ladies and gentlemen, welcome to the international webinar on photocatalysis for dye degradation, organized by Béjaïa University in collaboration with Hari Bhai Desai College of Commerce, Art and Science Pune from India. This event is an opportunity for all distinguished scientists, academicians, and researchers to listen to the eminent speaker who works in the field of photocatalysis. Once again, welcome to all participants. Without too much delay, I give the floor to Professor Hamish Dalila from University of Béjaïa.
Thank you, sir. So now it is my privilege to introduce the principal of Hari Bhai Desai College from India, Professor has his career in history. He has a teaching experience of more than 70 years. During his career, Sir has published 9 reference books, and Sir is an editor of 60 other books in history. He has started several short-term courses in the college. This includes certificate course in journalism, for guide courses, heritage work, and Modi. Also, Sir has delivered more than 15,000 lectures all over Maharashtra. As a freelance writer, Sir has published more than 1,000 articles in various dailies. He is founder trustee of Disha Development Trust, Pune. Professor Raoud visited London, Dubai for his advanced studies and in history. So it's my honor to give floor to principal, I think, principal of college, Professor Raoud.
Yes, madam.
Okay, welcome.
Yeah, thank you, madam.
Sir, you can start now.
Yes, yes.
Raut, sir.
I welcome you all on behalf of the Pune Gujarati Kelavani Mandals, Hari Bhai Desai College. This educational institute was started 75 years ago by the Gujarati Kelavani Mandal. From its beginning, the Pune Gujarati Kelavani Mandal has accepted the work of social service. H.V. Desai College was established for the purpose to provide education to all sections of the society. The college has a history of the last 4 decades. The college is located in the heart of Pune city. It's a cultural capital of Maharashtra. The college offers courses in arts, commerce, science, and computer science. The institution is dedicated towards providing the quality education from undergraduate level to PhD level. I congratulate Dr. VIKRAM PANDIT sir, Dr. Dalila, Dr. Fatmi, because the coordinators selected the great day in history today. Sherpa Tenzing Norgay of Darjeeling from India and Hillary of New Zealand conquered Mount Everest for the first time on May 29, 1953. So we remember that victory, and also we are going to think about that victory and it's a new step forward to mankind that HV Desai College and Algeria, or India and Algeria, it's a new beginning in the world of science and chemistry. So I congratulate Dr. Vikram Pandit, his colleagues, Dr. Dalela and Dr. Fatmi once again. Thank you very much. Thank you, madam.
Thank you, sir. So today we are pleased to welcome Dr. Pandit Vikram, a special guest from India. Let me introduce our guest speaker by saying just a few words about his own background. So Dr. Pandit Vikram currently is working as assistant professor and PG coordinator at Department of Chemistry, Haribhai V. Desai College, India. He is qualified national level chemistry exams. He completed the PhD with topic synthesis of organic, inorganic, and coupled semiconductor monostructure for photocatalytic applications. He published high quality and high impact factor research papers in international journals like Royal Society of Chemistry, Journal of Materials Chemistry, American Chemical Society, and Environmental Science and Technology. So, and also Journal of Materials Research and American Scientific Publishers. He is reviewer for high quality and high impact factor research papers like Environmental Science and Technology, Journal of Material Chemistry, and he was guest speaker at Al-Muthana University Republic of Iraq, Ishwarya Multiple Campus Nepal. He received Dr. P.B. Punjabi Award for Best Oral Presentation in India Council of Chemists Conference. His research areas of interest are synthesis of various nanomaterials and their nanocomposite materials for photocatalysis, water splitting, and complex organic dye degradation. So today he will be shared with us his expert opinion in the photocatalysis. With that, I ask that you give your full attention to Dr. Pandit Vikram and help me in welcoming him to the stage. Dr. Pandit, please. You can start.
Thank you, ma'am. Now it's my pleasure to give a talk on photocatalysis. Before that, I would like to thank my college's principal, Dr. Ganesh Raut, our secretary of PGK Mandal, then IQSC coordinator, Sagar Jagtap sir, Abhijit Pawar sir, and all my staff members, my friends. Also from Algeria, I would like to thank Dalela ma'am, Dean of Vijaya University and head of the department in chemistry of Vijaya University. Before I start, I just want to share one presentation. So I just want to show you where is my college located over here. Is it visible, the screen? Hello?
Your slide? I can't see your slide.
Just a minute, I'll share.
Yeah.
Yeah. Now is it visible?
It is visible, yeah.
Okay. So this is the world's map. Algeria is here and India is here. So just pay attention because we are going to get in India. Now this is the Algeria, here is India, and if you see, this is the Indian map. Inside the India, we are from here, Maharashtra. In Maharashtra, we are from Pune district. This is the whole Maharashtra, and we are from Pune. In Pune, we are from Haveli Taluka or Tahsil, and in Pune we have various historical places. So here there is a Shaniwar Wada is there, and exactly behind the Shaniwar Wada there is our college, HV Desai College is there. See, this is the Shaniwar Wada, and this building is nothing but our college. See, it is very big building. This is the entrance of our college, HV Desai College, Pune. So in our college, we have gas chromatography, then high performance liquid chromatography, then IR spectroscopy, and UV visible spectrophotometer. So with this high-end equipments, we are just doing a little research, and our students are very interesting in doing such a kind of research. With this brief introduction, now I would like to start my presentation. Today's presentation is on photocatalysis for dye degradation. Now, this slide is visible? Photocatalysis for dye degradation. Okay.
Yeah.
Okay.
So myself, Dr. VIKRAM Pandit. I am assistant professor and PG coordinator at Department of Chemistry in the Pune Gujarati Kelwani Mandals Haribhai Videsai College, Pune, India. So just I have taken all the names. So here I'm going to present 12 principles of green chemistry, then water pollution and its effects, then photocatalysis, photocatalysis setup, and for young researchers, students, PhD students, and few professors, I would like to show how they can work on their college or university level. So here, first of all, I would like to introduce the green chemistry. As we know that green chemistry means we should have to reduce the production of hazardous substances. Right. So green chemistry applies across the life science of all the chemicals. And since we are all from chemistry background, we are producing the various chemicals. Now here one should understand the sustainable development. So the sustainable development means we have to do the kind of research that will not be going to disturb present or the upcoming generations. For that purpose, there are sustainable development. We can achieve that by following the 12 principles of green chemistry. As we all know, this globalization, it leads to increase in the population, and because of the population we have to generate new industries for satisfy the needs of this demanding population. Now because of this industrialization, there is a very numerous amount of chemicals they are producing a pollution. So there are 12 principles and we are going to focus on all these 12 principles. But here this pollution, I want to focus on pollution first over here. So pollution, we all know from schools, we already studying that there are air pollution, then land pollution, noise pollution, and water pollution is there. Okay, for today's talk, I want to focus on water pollution. Here in water pollution, so many industries are there. They are working on a organic dyes. Okay, so dyes are nothing but such a very complex organic structures. Here in this picture, a man is doing a coloration to the jeans pants. We all are wearing a jeans pants, and the spent out or the remaining water which is colored, we are just throwing that into the water, right? So because of the high thermal and photo stability, this all the dyes and all the color solution, it will remain in the nature as it is. See, this is the pipe through which the industries they are passing the this kind of colored water into the rivers or water reservoirs. The effect of this is that the fishes which they are taking into the their body, they are dying. Once these fish come into the human body, there are so many dangerous cancers type of diseases happens. The very latest example, and because of this kind of disease or viruses, we are organizing this kind of only is the coronavirus. So there is a doubt in the origin of this coronavirus, that scientists, they have assumed that it might be come from the water. So this kind of chemicals, they are very, very affecting, or they are very dangerous to the human life. Now this picture or this problem, scientists have discovered like way before, like 100 years before, and there are so many treatment technologies are there, like chemical methods, physical methods, and biological methods. Since we are going to use this method, that means very expensive purpose. And this whole process will become so much expensive that we cannot afford, or the some countries or even some people, they cannot afford such type of expensive methods. So that in our HV Desai college, one of the student from microbiology, he helps me to demonstrate such a kind of an model as of in industry. See here, first there is a one industry, we have already labeled them as HV Desai textile industry, okay, Pune. So here industry, whatever the products they are producing, they can go and they can sell into the market. But whatever the waste it produce, that goes into the various tankers that will be stored for some time. And again, lastly, this red color pipe, it goes into the river. So whenever we search on internet, there is such a type of pipes are there, and these pipes goes into the river like 1 or 2 kilometers inside the river, and it dumps that waste into that river. Okay, so we thought we could work on this pipe by using the photocatalysis. Okay, so photocatalysis is very simple phenomenon over here. Its name itself indicates that photo means light, and catalysis means you have to perform a catalytic reaction over here. So the sun is a very abundant source of a light, which is a free, which is everlasting. So we can take this. If you have a catalyst means any semiconductor nanomaterial or any type of material, it will have a valence band and conduction band. As the sunlight falls on the valence band, the electrons will go in the conduction band, and there is a reduction process happens, and again holes are responsible for the photo oxidation. We will see this, what is photo oxidation and reduction process. But as I have told you, we required a catalyst, and that photocatalysis is helpful for us to generation of hydrogen, or to generation of hydrogen from water as well as from H2S gas. We all know this H2S is very, very dangerous. It causes a pollution. We can produce a hydrogen of it. We can produce a hydrogen from water, hydrogen and oxygen. Now in India, from last couple of months or like 3-4 months, we are facing a very big problem with the oxygen. We can produce oxygen by using this kind of method. In HV Desai college, we can produce oxygen, but there is a very big problem with this, its storage. So that's why there are few limitations are there. So today, instead of talking on this hydrogen, I have selected on talk on the dye degradation. So for that purpose, we have a sun. Now I want a nanomaterial. So nanomaterials can be synthesized by various methods, and all these curriculums of students, they have included now this type of processes. As I was I am discussing with Dalaila ma'am, that we are going to take a one more webinar or some kind of a lecture on the nanomaterials only. So just we will focus on this problem of dye now. Here this dye is very, very dangerous, and in HV Desai College, in our Haribhai Desai College, we have such a photocatalytic reactor setup where we can do this kind of photocatalysis reaction. This type of setup is there where right. So that's why, again, with my postgraduate project students, we have developed such a reaction setup on the rooftop of this very building. Here, if you see, there are only magnetic stirrer and conical flask with the electricity is there, and the sunlight or the source of light is here is the sun. Again, here, when during my PhD timing, I work in the Center for Materials for Electronics Technology, Pune. There also they are having a very good setup for the degradation of dye. So I have showed you like a couple of setups over here. You can generate, you can degrade dye or in this setup, as well as you can take this kind of stirrer and solution onto the rooftop of your building, and we can produce such a kind of a setup over here. Now here, instead of, if you don't have anything, you can do this type of research or work at your college, at your university also. So this is a very basic and small process. Before this process, I want to show this setup again. Here, see here what is there. There is a one magnetic stirrer. On the magnetic stirrer, we have a conical flask. In that conical flask, we have made a solution of methylene blue dye. Here, in the methylene blue dye in the conical flask, we have added a nanomaterials. So nanomaterials act as a catalyst over here. Again, there are a lot of things that we have to keep in mind before adding any nanoparticles to this solution. Titanium dioxide, zinc oxide, or tin oxide are the best candidates for this type of a dye degradation setup. Here, the lamp is there. This lamp is having a water jacket from outside. If you see, there is a pipe. This pipe is coming from this water taps. So it is one is a inlet, one is outlet. So it will keep cool this lamp. So that's why there will be no overheating and there will be no any breakage of this kind of lamps will happen. Also, to this box, from the back side, we have a fan. That fan will regulate or the temperature of this whole box will be maintained. So once we do the all the arrangement, we just simply close the door, and you can see here, if you have seen it from the inside, here there is a display over here. As we are using a UV light or UV source here, that will be very, very dangerous to our health. So this is our staff is also we are means he will be working on with me, and there will be very good results. Now see, all the parameters we can set through these tabs from outside. No need to catch any kind of UV radiation, so as to avoid the UV radiation and its harmful effect, we have to stay outside only. So such a setup we can do in any college, any lab. After start of this UV light, after interval of 10 minutes, you can take this solution out, you can take its UV visible spectroscopy, and that type of process is there in the next slide over here. See, now this work you can do at your college or in the university also. For that purpose, even if you don't have UV visible spectrophotometer, every lab will have this type of a colorimeter. So the colorimeter will give us the monitoration of such type of a light. So what we have needed for here, the apparatus are very simple. We require a magnetic stirrer, we require a conical flask, we require a set of a test tube stand, and finally if you have a UV visible spectrophotometer, then it will be very good. Otherwise the colorimeter can also do the same kind of work. What we needed then, its procedure is very simple. In the procedure, you have to take a dyes. See, there are number of dyes are there. For example, methylene blue, methyl orange type of dye, alizarin type of dye. So many dyes are there. You have to take a dye. We have to prepare its ppm level solution, parts per million. There is one trick. If you want to prepare any ppm solution, you have to take that much milligram of solid dye and dissolve it into 1 liter. For example, if I want to prepare a 100 ppm solution, then I will take 100 milligram and I will dissolve it into 1 liter. So that will give me a 100 ppm solution. So I know the concentration of solution. Out of 1 liter, I will take only 100 ml solution into this conical flask for you. Then I have to add a magnetic needle and I have to add a catalyst. So now again catalyst synthesizing is very simple. You do not require any type of a special reactor system. You can do a number of nanomaterials in the lab in a beaker. There is a very famous method, that is a sol gel method. With the help of this sol gel method, you can synthesize a number of nanoparticles in the, I can say, a graduation level lab. No need of any specific type of compounds required. So here, if you have catalyst, you have to start the stirring and we have to keep this under the sunlight. Even in actually here in the HV Desai College in my lab, we have this setup near to window. Okay, earlier what we to use, we are just keeping our magnetic stirrer here instead of this setup, and even in this coming sunlight we are doing such a kind of a example, such kind of a dye degradation with various dyes. So now we have a solution, we have sunlight, we have catalyst, we have to keep stirring this solution. Now we have a dropper. So with the help of dropper, after interval of 10 minutes, I have to take a 2 ml solution out of it. I have to keep into the test tube. Then we can label it like 1, 2, 3, 4 or 10, 20, 30, 40, 50 and 60 for 1 hour. So such a type of study we can call it as an kinetic study, right? So this kind of kinetic study we can perform. After doing that, if you have a UV visible spectrophotometer, yes, you are using a water for making a solution. You can use a water for baseline. You have to do the baseline with the help of water. This is the UV visible spectrum. For first solution, you have to go from the last reading. That will give us the less error. So that will give you the spectrum, and once you go to the final, this will be the like a pure solution that you have prepared at a 10 ppm. That will be like a 100 ppm solution. Now if you observe at 0 reading, you will be having a absorbance is around 1.2, and after 1 hour or after 2 hours, you are getting a result like this, like 0.2, 0.0 something. Okay, so as I have showed over here, so this as it is going down, that means there is a decolorization happens. Decolorization means we can reduce its color, right? So this type of phenomenon is known as a decolorization. If you prove that this compound here, which is present as a dye, and at the end of your experiment solution, this If you prove that there will be no any organic compound, then this kind of experiment is known as a degradation. Decolorization and degradations are two different phenomena are here. If you have taken mass spectra, GCMS of this, LCMS of this compound, you will get a peak for methylene blue dye. And if you have taken mass of this liquid, you will not find any peak for this type of a methylene blue dye. That means there is a total degradation takes place. With the help of mass spectrophotometer, we can do this type of a degradation. We can prove that degradation takes place over here. Now what we have all these parameters. We have to just simply do this type of a kinetic experiment. This experiment is very similar to the graduation level physical chemistry experiment. So we do not need any type of a special reactor. We do not need any type of chemicals, or even we do not need any type of a instrument over here. Once we have this type of solution, we have to perform its UV visible spectrophotometer study. We'll get such a fix. Now here, just make a list of absorbance with respect to time. At 0 time, we have 1.2. Then at 20, we have 0.6, 0.8. Then as decreasing, and at the very few or after 1 hour or 2 hours, you are getting a reading as an 0. See, from starting from 1.2, now we rest on the 0. That means we have degraded this kind of compound. If you are able to prove with the help of its any type of a spectroscopy, then it will, we called it as a degradation. Otherwise, it will be a decolorization. Now, as we know, we have this kind of all the readings. We can plot a graph of it with respect to time. So at 0 time, here 0, you are having a 100% dye in your solution. As time passes, see, we go to the 20 minutes, then there will be a very less 50% dyes remain. As we go further 40 minutes, there is again some 50 or 45% dye is there. As we pass the time, after 2 hours, we have a almost 40% dye remain in there. So this experiment we did with the help of one of our catalyst. Okay, this is the results of only single catalyst. Now what we did, we can add a best catalyst, that is a titanium dioxide into that, and after a addition of 0.2% of this TiO2 with this dye or this compound, what we have seen, see the observation. At 0 time, we have 100% dye. As time passes, within a 60 minutes, within 1 hour, we have degraded all the possible organic dye over here. So this reading is almost 0. So starting from a complex organic compound, we rest with only CO2, then water, then CO. So as compared to these organic compounds, these compounds are in gaseous form and they are less toxic as compared to any organic compound. So this is just an observation. After this, one can find its rate. So for doing the rate, we have to take ln of these values, and again we have to plot it against the time. So we will get a straight line of graph, and you can find the rate with the help of a slope of these lines. Again here, starting from 0, when we have used one catalyst, its name is like a PQ over here, we will get a very less degradation. Rate is increasing now here, and for this 0.2%, we got a straight line, and that is nearer to the y-axis over here. So we just tabulate all this result over here. We have this 1, 2, 3, 4 type of catalyst, and here for this catalyst we have only 0.8 into 10 raised to minus 2 per minute rate, and as we goes on increasing the amount of this catalyst into the titanium dioxide, we got almost 5.8 into 10 raised to minus 2. So almost it is like 6 to 7 times faster and quick of this type of a reaction. So these results we publish in American Chemical Society's Energy and Scientific Journal. So these are like a very good type of result. So again, I just want to share this, that if you have a very small or very common apparatus in the lab, we can do such a type of a kinetic study. Now, if you want to publish in good publication, what we have to do? We have to replace this dye with another dye. We have to do the literature search. What we have to find, that by using a catalyst, can anybody do this kind of degradation? If it is not there, you can do it with the help of students, with the help of your teacher also. And the results can be published in good quality of journal. Why? Because as I have told you, this water purification and water pollution is a very challenging issue nowadays, as we are all facing corona. So that can be removed by using such type of experiment. So this is the just general very important, that we do not require, even if you don't have such a kind of box or such type of dye degradation setup at any college or in any industry, we can do simply with the help of these very common instruments, and we have to publish, we can publish it into the good quality journals. Okay, so this part I want to describe, or I want to present in front of you. Thank you very much for listening. Hello. Now,
Thank you, sir.
I think if you have your questions, you can put it in a chat box.
Yeah. So I think my colleague, Dr. Fatmi, has one question. The first question. Please, sir.
First,
Yes.
I would like to thank you for your presentation, which was very clear. I would like to have your opinion about on the substance which will be generated after photocatalysis concerning their toxicity.
So can you repeat, please?
Okay, we do.
Yeah.
I would like to have your opinion on the substance which will be generated after photocatalysis concerning their toxicity.
Yes, toxicity, about toxicity. See, as I have told you first, the 12 principle of green chemistry here. Yeah. So in the green chemistry principle, we are focusing on the atom economy. So these dyes, they are having a very dangerous effect on all the aquatic life, as compared to this solution which we are getting after photocatalysis is having a very less type of effect, and that have been published more than like every year. There are thousands of papers are there. I can share this paper with you.
Okay, thank you. And about analysis method, I saw that in your presentation the method used is ultra UV visible.
Yes.
For quantification. in my opinion, the best method is HPLC.
Yes, see, in here in India, we have a UV visible spectrophotometer, which is very common. Okay. And in HPLC, we will get a single type of a peak over here. But for getting a like a average peak, we are using a UV visible. Not only the organic compounds, but we can find the color change by using UV visible spectrophotometer. That's why we are using UV visible spectrophotometer over here.
Okay. Again, thank you very much for your presentation.
Thank you.
Thank you. So my question is, if I am working on composite materials or non-composite materials, can I use these materials to do this experience?
Okay, so this there is a only one basic that you have to follow. You have to use the semiconductor type of a catalyst. What is the meaning of semiconductor? That means there should be a valence band and conduction band there. Only the electrons and hydrogen, they will be responsible for such a type of a degradation.
Okay, thank you.
So if your composite system is in the semiconductor scale, you can use it. If you don't use, if you don't have a semiconductor, you can add any semiconductor into your system. Then there will be definitely some degradation will take place. Okay, I can see here Pankaj Keshri. He asked, please share your published paper. Okay, I will share on the group if you want. You just search on the internet as an Vikram Pandit Google Scholar. There will all the papers are there.
Okay, so Dr. Kugal has a question. Sorry, Hand has a question. He says, which kinetics is followed by this reaction?
First order, as we can see, first order of the kinetics are followed by using such a kind of reactions.
Okay.
There is one more question, I think. Swapnil Doke. Shall we synthesis TiO2 and RGO composite, and can we use composite as a catalyst in the electrode for COVID-19 detection biosensor? Okay, so already I think RGO and graphene based electrodes are already been there in under testing. We can use this type of detectors, but before that we have to do a lot of testing. If we found this as a it will give a quick response, then definitely we can use it. Again, there is one question. This process is used for photothermal therapy. Photothermal therapy, sorry, I don't know about much about this photothermal therapy. Okay, I'll search it on this photothermal therapy. Okay, my colleague, my head, Dr. G.S. Google have one question. Now people have suggested use of methylene blue on COVID-19. What is your opinion? Sorry, sir, I didn't see any type of report that you have to share it with me. I will be very happy to read about this methylene blue and COVID-19. Thank you. Pankaj Keshri asked again, target drug delivery. Yeah, this type of reports are already been there. That target drug delivery by using nanoparticles we can definitely use.
Okay.
Okay. So, is there other question? I think. Anyway, we will share your email.
Yeah.
I think anyone can take part with you. And
I will put it here in chat box if anybody wants that my email. Okay.
Yeah.
And I wish that your students from Algeria, if they want to ask me any question, I will be happy to answer.
Yeah. First email. Yeah. How first order kinetics is confirmed? I think there is another question. How first order kinetics is confirmed?
Okay, we are using a Langmuir type of. There are formulas. Certain formulas are there. Okay, by using that formula, and dye degradation is like I think a more than 100 years old technique, and such type of papers, and they are publishing now and then. So very good research papers are there. They have proved that this is like a first order kinetics. It is there.
Okay, thank you.
You can read this comment, it's good.
Everyone, thanks you for your nice presentation.
Thank you. Still, I think we have a 5-10 minutes. If anybody want to ask, I will happy to answer.
Yeah, I think there is another question. He says, is there any report regarding copper graphene composite for H2 productions?
Just a minute, I have to see. Okay. Is there any report regarding copper graphene composite for hydrogen production? I think, yeah, with the help of copper and graphene, there are so many publications are already been there. You can just search on internet, put it this copper and or slash graphene nano composites. Copper, there will be a lot of information will be there.
Okay. Okay. And what kind of information of characteristic observed using UV spectroscopy?
So by using UV visible spectroscopy, we can get information that its color is changing or color is decreasing absorbance value. As absorbance value is decreasing, that means there is a definitely a decolorization takes place. So that kind of information we are getting with the help of this UV visible spectrophotometry for this experiment. Again, if you want to, if this question is like a generalized question, with the help of UV visible spectrum, we can find a band gap of a material. So that is useful.
Okay, thank you. Congratulations, very nice presentation. Okay. I think there is no question now.
Is there any question?
No.
Can you see any question?
No, there is no question, but I think there is your email and anyone can send you the email and you can answer by email.
So the email is already been given there in chat box.
Okay, there is another question, I think. Like graphene, biosensor, can we make a sensor for SARS-CoV COVID-19 virus detected using another catalyst? There is another question by Pratik Bankar.
Google sir, you can speak if you want. Just I'll first. Just a minute. There is a. I think one question has been asked.
Okay.
Okay, like a graphene EBIT biosensor, use of methylene blue. Yeah, just as I told you, sir, Google sir just mentioned such a new invention. I have to search it on Google. Then we can talk on it.
Okay, wonderful, Dr. Vikram, sir.
Yes, sir. Yes, sir.
I'm really proud to be associated with you. And this work, even we are also working on the same. My question is that you are using it for the, wastage problem, water waste or something like that. But if we can make a proper report, and if we subject, if we report,
please,
government
will you please talk a little louder? It's difficult to.
Okay, am I able to you?
Yes, yes.
Yes, we can really a fantastic, wonderful presentation. First of all, I appreciate. I am really proud to be associated with colleague like you. Now we are also working on the same. Vikram sir, one question that you are using it for the wastage problem, water waste or something like that. If we can make a report, and if we are presenting such a presentation to PMC authorities, state government authorities, or any admin authorities, it will be more useful for the pollution, water pollution control in Pune. It's like Mura Mutha, what we are facing. What do you think? Can we make such a presentation?
So as I have told you, this type of research is very, very old, and there are a lot of agencies and engineering students. They have patents on this, and they are already been using with the government authorities. They are already been in market. Now here, being a chemist, what is our role so as to discover a new type of a catalyst system? Again, if you want to give a then this should be performing a number of reusable cycles. Like if you use it once, it can be used again and again. Then only we can do such a kind of an invention with the any type of authorities.
Yeah, why I have asked this question? We are a very smart in chemistry. That is the question. But commercialization of chemistry is made by other people, or some other people. But if we can work on this,
yeah, I think that there should be a protocol for that. If our college already been having such a kind of any person is doing that, I will be happy with doing on the steps of those teachers or professors. But even in my PhD center or in various national institutes, very less people they are doing such a type of invention. So if it is there, we can try for that, no doubt. Thank you for suggestion, sir. Yeah.
Only one question. You showed one photograph along with our staff member, Mr. Arvind. That instrument is shown. I would say there is a UV, and these people are not the chemists as such. I mean, say lab people, lab peon or lab attendant. Is that UV radiation is going to harm the operator?
Yeah, there I have showed two type of setups. First is in sunlight, so that will not be making any trouble thanks to ozone layer, right? And second thing, that this setup which is we just brought in COVID period, this setup is so automatic that if anybody by mistake put the UV radiation on, and if you just go in the area, that will not be that that if you open that door, it is automatic. If you open that door and if still the UV radiation is on, it will automatically get off. So there will be no problem with the UV radiation as such.
Okay, thank you, Vikram sir. I think we are
thank you, sir.
Out of college more than the college. Thank you, organizer from Algeria. I'm from Algeria. I forgot her
sir.
name. Bilagi. I'm sorry for pronunciation. Thank you.
Yes, ma'am. I think there are no questions now.
Yeah.
Okay. Give him again.
Okay. Dr. Pandit, thank you so much.
Thank you, ma'am.
If you have anything to say at the end of this event, we are listening.
Yes, I would like to thank all the students, teachers, your deans, especially your head of department, and especially to you
Thank
that
you.
you have organized such a very good event. My
It was a pleasure.
colleagues, my head of department, Google sir, there is a Hande sir, then my staffs they are joined, then Abhijit Pawar sir, IQC coordinator Sagar Jagtap, then principal Raut sir, secretary sir, all of you. Thank you very much.
Thank you so much.
Bye.
So
Bye.
I am grateful for having had the opportunity to coordinate this event together with the University of Bijaya and Harib Bhai, the VDC College. Now that we have come to the end of this event, I would like to express my warmest thanks to everyone, and a special thank you goes to Dr. Pandit Vikram. At the end, I want just to say one thing to our students. I want to say, do what you can with all you have, wherever you are. You are never too old to set another goal or to dream a new dream. The future belongs to the competent. So get good, get better, and be the best. So thank you once again, and goodbye. I hope that will be another webinar very soon with you, Dr. Pandit.
Yes,
Thank you,
thank you, ma'am. We are also hoping for the same. Thank you.
Okay. Goodbye and thank you again. Je ne sais pas, on peut couper. Je ne sais pas, mais il va dire. Arrêtez de mettre en évidence. Arrêtez.